Hello and welcome back. Enrichment, series, summation, series integration, my favorite topics. So we're trying to find the sum to infinity. It's written in sigma notation of numerator 2r plus 3. And here this is not 3r, is 3 to the power of r bracket r plus 1. Okay. How are we going to find something like that? First of all, I'm going to do some manipulations which do not involve series as such, just to make this summand a little bit easier. So I'm going to do it down here. So I'm going to, first of all, just look at, forget about the 3 to the power of r, just this fraction here, 2r plus 3 over r plus 1 is equal to 2 bracket r plus 1 divided by r plus 1. I'm just basically splitting the fraction instead of doing a long division. So if you see what I've done is I balanced, that's the 2r there, plus 2 plus 1 is 3. And of course, this will allow me to split the fraction to that divided by that, which gives me 2 plus 1 over r plus 1. So this is just this quantity here. So when I write now my sigma, I can actually write it as two separate sigmas. So we're going to have from r is equal to 1 to infinity, 2 over 3 to the r. So that is this bit here, from this quantity here, plus another sigma. And on the other sigma now, we're going to have that's a 1, so we're going to have a 1 over r plus 1 times 1 over 3 to the r. And perhaps I should have actually written a little bit differently. It's a little bit too late now. Maybe I should. Maybe easier to actually see it. I should have really either written it as 3 to the minus r, or maybe better, a third to the r would have been better. Maybe I should actually write it, at least for this one here, I can write it a third to the r. And this, it doesn't matter now, I can't be bothered. I left no space. All right, where do we go from there now? All right, is this difficult to sum? This is just nothing but geometric progression. Is actually, if you look at what terms we're getting for this quantity here, this particular sum is going to be, of course, 2 over 3 plus 2 over 9 plus 2 over 27 plus 2 over 81 plus dot dot dot. So this is now a GP with first term equal to 2/3. Common ratio is going to be 1/3, and therefore the sum to infinity for that is going to be a over 1 minus r. So it's going to be 2/3 over 1 minus a third. Standard formula, sum to infinity for a GP that converges to the common ratio numerically less than 1 is going to be a over 1 minus r, a very famous result. So it's going to be a 2/3 divided by 2/3, which of course is equal to 1. Okay, a little bit unexpected, but it's just a 1 in there that I've got. Okay, that's only for the first quantity. Okay, so let me just perhaps put it in a circle so don't lose this bit. And let's say this is equal to 1. Very simple result. Now the question is, what do I do with this particular sigma? This is not easy to see at all. There's no, obviously, a standard result. It's got something which is like a geometric progression, but it's got extra bits which are not even of the form, some kind of integer or a square of an integer, 1 over. There is no method of differences because I cannot produce partial fractions out of anything like that. So something which looks like that, if I look carefully, I'm looking perhaps to compare it with a series expansion, standard Maclaurin. So what comes to my head is this expansion here. So I'm going to experiment a little bit. So I'm going to look at the log of 1 plus x, okay, and I will just see what happens. Let's like the expansion first of all. That's x minus a half x squared plus a third x cubed minus a quarter x to the 4. I can see straight away this is not the 1, but it's actually related to this one. Let me explain what am I looking at. First of all, when I put x is equal to a third in there, and let's remind ourselves, this is works for x, I think is bigger than -1 and less or equal to 1 or something like that. I have to check. Log of 1 minus x, 1 minus, because I think it's the other one that we have to be careful. If we're putting 1 in there, we're going to get 0. So in fact, I think the equals on the other side. You can check it on the formula book. Like, it will take me a little while to actually derive the radius of convergence for this one. But without losing anything for our question, we can just say, okay, you know what? Forget about whether it's equal or whatever. We're not going to plan to put anything equal. The third will be working fine for us. It's definitely within that range. And if I put there a third to the 1, a third squared, a third cubed, not this a third, of course, a third cubed, a third to the 4, I'll be getting this term. But I have two problems. The problem number 1 is the signs alternate. And problem number 2, the powers don't match. For example, when I have it squared, for example, a third squared, so that's by putting in there, I will have 1 over 2. So these two will be exactly the same. And that's a bigger problem than the signs. Okay, so first of all, I can take care of the signs straight away, because of course, we should know that the expansion of 1 minus x, still in the log, produces everything negative. You might say everything negative, we have everything positive. Everything negative is good because we can make it everything positive. So now if we multiply both sides of this line by minus, of course we get a positive expansion. So far we dealt with the sign issue very, very easily. The question is now how we're going to deal with this difference in the powers that we got, the power there, and this the 1 over. The way I'm going to deal with that is, what am I trying to do? I'm trying to make this bigger. Okay, so what I can do is I can divide both sides of this equation by x. So I can say minus 1 over x log of 1 minus x. Quite clearly, it's going to be, I'm dividing by x, so it's going to be 1 plus a half x plus a third x cubed plus, not x cubed, sorry, I didn't divide this one because I'm stupid, because I went absent-minded, a quarter x cubed plus dot dot dot. Now, if I put, of course, x is equal to a third in there now, so it's going to go a third squared, let's say on this term here, then this term will be 3 here, which is of course 2 plus 1. If I put x is equal to a third on the x cubed term, then of course this term will be 1 over 3 plus 1. So this is in fact will be matching this summation, but not all of it. What is the first term from this particular one? So the first term, when I put r is equal to 1, is going to be a half times a third to the 1. So this bit I don't want. Okay, no problem. So let's see what we can easily get rid of this one. So I hope you're following what I'm doing so far. I'm just manipulating and trying to get this sigma to match something known, and I found it. Now, this quantity, minus 1 over x, log of 1 minus x, minus a 1, I subtract this 1 to the other side, is in fact equal to sigma of 1 over r plus 1, x to the r, from r is equal to 1 to infinity. And we can check, this is basically all these terms. When I put r is equal to 1, it's going to get 2, r is equal to 2, 3, and so on. And the powers, of course, are going to be 1, 2, 3, and so forth. This is what I've got in there, but I have the third to the r. Can I substitute in this expression x is equal to a third? Absolutely yes. So what will I get? Minus 1 over a third, log of 1 minus a third, minus a 1 is of course sum from r is equal to 1 to infinity, 1 over r plus 1 times now a third to the power of r, which of course my quantity there. What will that simplify? This will now simplify. I'm going to write it because I don't know if it's going to be visible in the video if I write any lower. What is that? Well, that is in fact equal to negative 3. 1 divided by a third is 3 with a minus log of 2/3. Okay, minus a 1. So in fact, I just found, because of course this is what I was after, this quantity here is in fact equal to minus 1 minus 3 log of 2/3. And the rest, of course, is now history. It's game over now. It's all finished. It's just a case of the time it takes me to rub this off. We should just have an answer in the simplest form. This particular series, we have 1 minus 1, goodbye my friend, minus 3 log of 2/3. And of course, I don't like that negative 3 at the front. Let's put 3. And of course, we're going to flip the argument of the log. And this is in fact the answer to this particular sum. Where is this question coming from? I was browsing in the student room the other day, and some poor guy, he said in his further maths textbook, he had this particular problem. I tried to help him and I said, this is not possible. There's something wrong with the question, it's possibly a typo. He had to find this particular sum. It's exactly what I've got in there. But of course, it wasn't to infinity, it was to the power of n. And it clearly, somebody else pointed out this problem has come up a few times in the past. There is a typing error in his book. I think there was an extra r on the denominator that's missing. And I said to him, look, after I tried the question, this is impossible to sum to n, but to infinity, I can sum it for you if you want. And this is how this question came about. Anyway, I hope you enjoyed it. There was quite a lot of skill involved. Series are very, very beautiful if you get your head around it. I will be doing more of this in the future. For the time being, I'm signing out. I'll see you soon.